Roger, LF. Understand you are on the bottom. Congratulations, Victor. Congratulations.
The deep ocean is not just dark. It is a place of crushing, unimaginable pressure. At 11,034 meters in the Challenger Deep, the water weighs over 16,000 pounds per square inch, 50 times the pressure in a rifle barrel. But during a recent descent, researchers detected something drifting in the darkness that should not be there. It was not a machine, and it was not a living creature, and scientists struggle with what its presence means. The Mariana Trench. Scientists exploring the deepest place on Earth recently stumbled onto a revelation so unexpected that it is forcing a re-evaluation of how life survives in the planet's most unforgiving environments. At the very bottom of the Mariana Trench, far below the reach of sunlight, far below the limits of human endurance, they discovered what can only be described as a methane-powered seafloor, quietly feeding hidden ecosystems in the dark. To understand why this discovery shocked researchers, one has to appreciate the sheer scale and brutality of the Mariana Trench itself. This colossal geological scar stretches in a vast crescent through the western Pacific Ocean, positioned east of Guam and roughly 200 kilometers east of the Mariana Islands. It descends like a wound carved into the crust, extending for almost 1,580 miles and averaging 43 miles wide. And at its deepest point, the Challenger Deep, the seafloor plunges to an overwhelming 36,037 feet, give or take 82 feet. That depth is nearly 7 miles beneath the ocean's surface. To put this into perspective, if Mount Everest were lowered into the trench, the mountain's peak would still sit more than a mile underwater. Down in this cold and silent abyss, the pressure reaches a crushing 16,000 pounds per square inch, 50 times more than the pressure inside a rifle barrel. It is the closest thing Earth has to an alien world. Yet, in this hostile environment, something was growing in the trench. The reason the trench exists at all lies in the powerful forces of plate tectonics. This is where the massive Pacific Plate, one of the oldest and coldest slabs of oceanic crust on Earth, up to 170 million years old, collides with the much smaller Mariana Plate. Unable to ram directly into one another, the Pacific Plate bends and dives beneath its neighbor, sinking deep into the mantle in a process called subduction. As it sinks, heat and pressure force water out of the descending rocks. That water rises into the overlying mantle, causes it to melt, and forms magma that eventually builds the volcanic islands of the Mariana Arc. This trench and volcanic arc pattern is the same engine that shapes the entire Pacific Ring of Fire, a chain nearly 25,000 miles long, responsible for 90% of the world's earthquakes and 75% of all active and dormant volcanoes. It is in the Mariana Trench that the forces that continually recycle the planet's crust reach their greatest depth. But the trench has not given up its secrets easily, and humanity's attempts to measure its depth have been cautious. In 1875, the HMS Challenger expedition first measured part of the trench using nothing more than a weighted rope, reaching 26,850 feet. In 1951, the HMS Challenger II used echo sounding to measure 35,760 feet, officially naming the Challenger Deep. Later surveys refined these numbers. A 2009 mapping mission aboard the RV Kilo Moana recorded 35,994 feet, while a 2010 University of New Hampshire survey measured approximately 36,070 feet with even greater accuracy. But none of these high-tech surveys hinted at methane seeps. That discovery required deep-diving vehicles capable of withstanding impossible pressures, machines that could descend into a world where even hardened steel can deform. And when they finally reached the bottom, what they found was quite astonishing. Instead of a barren, desolate seafloor, they found billions of tons of colorless gas locked inside rocks that lie between Earth's crust and the mantle layer. Thin, white microbial mats spread across the sediment like ghostly carpets. Chemotrophic bacteria fed on methane and sulfates, forming the first link in an ecosystem that had built itself entirely around chemical energy rather than sunlight. The methane seeps produced no dramatic jets or thermal plumes. They were calm, steady, almost serene, yet powerful enough to sustain life in a place previously thought sterile. But the strange methane-fed ecosystem was only the beginning. As scientists reviewed hours of trench footage, something far more familiar and yet infinitely more disturbing emerged. Because hidden among the natural wonders of the abyss was a presence that did not belong to any environment on Earth, let alone the deepest one. Plankton or plastic. A 2025 study has revealed something horrifying floating at the bottom of the deep sea, and the scariest thing is that it is the kind of intruder that never dies. At roughly 36,000 feet inside the Mariana Trench, the deepest known piece of plastic has now been discovered. One might imagine it is a lost piece of deep-sea equipment or an industrial part, but scientists have identified a grocery store plastic bag while carefully scanning decades of footage from the deep-sea debris database, the massive archive of images collected during 30 years of abyssal exploration. What made the discovery terrifying was not merely its depth. It was the realization that this cheap, weightless object had survived a journey through crushing darkness that only a handful of humans had ever endured. Jacques Piccard and Don Walsh reached those depths in 1960, and James Cameron followed in 2012, descending to 35,787 feet. Victor Vescovo later claimed to have pushed even deeper. These missions required reinforced steel hulls and vehicles built to withstand pressure strong enough to implode a submarine like an empty tin can. The plastic bag required none of that. It simply sank effortlessly into a world where no sun has ever reached. When scientists combed through the database, they noticed an unsettling pattern. Out of every object they could classify, plastic dominated the abyss. Plastic bags were the most common form, followed by disposable bottles and single-use cutlery. What made matters worse were the images showing that 17% of the photographed debris had already interacted with marine life. Some animals were tangled, others were trapped, and some had clearly attempted to eat fragments that would never break down inside their bodies. In the absolute silence of 36,000 feet, these creatures cannot flee the threat. They cannot escape. The plastic moves with the currents and settles into their world like an intruder that never dies. Another recent study examined amphipods collected from 6 deep-sea trenches, including the Mariana, and every single specimen contained microplastics. These small, ghost-white crustaceans, built to endure pressures that would crush aircraft steel, are now being slowly poisoned by particles lighter than dust. Every bite they take, every filter of water they pass through their system, quietly fills them with fragments of humanity's waste. Even more disturbing, scientists discovered that certain regions of the Mariana Trench contain higher levels of chemical pollution than some of the most contaminated rivers in China. The chemicals are believed to come from the breakdown of plastic as it sinks through the water column, fragments releasing toxins into a place already shrouded in eternal cold. Where does all this come from? Although some of the debris falls or blows directly into the ocean, a major 2017 study showed that most plastic waste first travels through 10 major rivers. The Yangtze, Indus, Yellow River, Hai River, Ganges, Pearl River, Amur, Mekong, Nile, and Niger funnel enormous quantities of mismanaged waste from densely populated regions straight into the sea. Initially, researchers believed these 10 rivers were responsible for nearly 90% of all riverborne plastic entering the ocean. But limitations soon emerged. The model was too simple, relying mostly on population density and waste estimates. Then came the advanced 2021 study in Science Advances, using a high-resolution global model that analyzed rainfall, terrain, coastline distance, and fine river networks. What it revealed was even worse. The problem wasn't confined to a few major rivers. Thousands of smaller waterways collectively flushed more plastic into the ocean than the giants ever had. The Philippines, India, Malaysia, and Indonesia became some of the largest contributors. not because of a few massive rivers, but because of countless smaller ones that rapidly carry waste into the sea during heavy rainfall. And then there is the plastic no one talks about: discarded fishing gear. A study found that most of the Great Pacific Garbage Patch, a floating mass the size of Texas, is made of abandoned nets and lines drifting between Hawaii and California. If plastic could appear at the bottom of the deepest trench on Earth, what else could be down there? Well, scientists have discovered something more. A sort of creature nothing like the megalodon, but dwelling in the deepest parts of the ocean. And no one was prepared for how it looked. Deep sea nightmares. In the deepest parts of the planet, where pressure rises by 1 atmosphere every 10 meters, the ocean becomes a brutal forge capable of crushing steel. At 8,000 meters, the force squeezing a living creature is 800 times greater than what humans experience at the surface. At these depths, the rules of biology falter. Membranes collapse. Cells simply stop functioning. And yet, in this impossible environment, something lives. The Mariana snailfish, Pseudoliparus suirae, is one of the strangest and most unsettling animals ever discovered. When explorers first captured footage of it drifting through the trench, it did not resemble anything familiar. It looked like a ghost, a pale, gelatinous specter with barely formed bones, a skull that does not fully close, and skin so translucent it seems carved from frozen fog. But its appearance is only the beginning of the horror. To survive pressure that should annihilate it, the snailfish depends on a biochemical shield called trimethylamine N-oxide, TMO. The deeper the fish goes, the more TMO fills its tissues, thickening its fluids until they resemble a cold chemical brine. Scientists discovered a terrifying limit. Between 8,200 and 8,500 meters, a fish's internal chemistry becomes so concentrated that it matches the salinity of seawater. Beyond that point, no vertebrate can survive without evolving an entirely new way of balancing salt and water, something no species on Earth has ever achieved. This means the snailfish lives on a razor's edge. If pollution forces it to flee deeper than its body allows, extinction is not a possibility, it is a guarantee. Even in the darkness, the snailfish has rewired its senses. It has lost nearly all color vision genes, keeping only a dim light receptor known as RH1, while auditory genes sharpen and expand. It is nearly blind, yet deeply aware of every vibration, every movement around it. Its body looks fragile, but its predatory efficiency is ruthless. Stomach studies show that 97% of its diet is amphipods, crustaceans that swarm the trench like drifting embers. This creature thrives in the very place human imagination once reserved for giants like the megalodon. But the reality is far more disturbing. The deep sea does not need massive monsters. It already has horrors far stranger. For example, the living vacuums, also known as the sea cucumbers. Despite their harmless name, sea cucumbers are among the most unnerving shapes crawling across the abyss. With elongated, unblinking bodies and pale, featureless skin, they resemble half-formed creatures still waiting for nature to finish sculpting them. They have no lungs and no air-filled cavities, only 2 internal respiratory trees that pump seawater disturbingly close to their digestive tract. Food is nearly non-existent at such depths, so sea cucumbers swallow the seafloor itself. They ingest mud, digest whatever microscopic nutrients survive within it, and expel the rest as processed sludge. Some species even rise off the ground, paddling upwards with a wide, fin-like web until they drift like corpses suspended in the water column, a sight explorers compare to watching something dead decide it wants to float. Then come the armored cerubins, strange abyssal fish that reject the idea of swimming entirely. Instead, they walk. Using thick, stiffened rays from their pectoral fins, they drag themselves across the seafloor, one deliberate step at a time. Beneath them dangle long, branched barbels, grotesque whiskers covered in taste buds that sweep across the sediment like searching fingers. Watching them move feels like witnessing a machine designed for a world of pressure and silence, a creature built more to endure than to live. Yet nothing in the abyss prepares explorers for siphonophores. Related to jellyfish and corals, these colonial organisms drift through darkness in shapes that defy logic. They are not single creatures but colonies, chains of specialized bodies, each performing one task: swimming, feeding, defending, or reproducing. Some siphonophores glow like threads of living starlight. Others resemble skeletal structures drifting through the void. Many are longer than whales. Most are so fragile that they disintegrate at the slightest disturbance, creatures built from light, movement, and silence. They haunt the depths like phantoms, their forms too delicate to belong to any world that makes sense. Every creature in the abyss shares the same fate. Evolution has stripped away everything unnecessary and replaced it with adaptations that seem alien, even monstrous. Bones soften, eyes fade, colors vanish, bodies flatten, swell, elongate, or turn to transparent gel. And now, with pollution creeping into even their darkest sanctuaries, these creatures face a new threat they were never meant to fight. If forced deeper, many will cross the biochemical line their bodies cannot survive. If forced to adapt, they may become something stranger or simply disappear. Despite the mightiness of the deep ocean and how it may twist biology, it is not in fact immune to reshaping as well. Humans have begun to uncover structures in the sea that challenge the assumptions of what should be under the sea, and what these changes mean for history is terrifying. The sunken cities. In the year 2001, marine engineer Paulina Zalitsky and her husband Paul Weinsweig swept their sonar across the deep waters off Cuba's Guanahatabibes Peninsula and found something no one had expected. At depths ranging from 600 to 750 meters, far beyond sunlight, far beyond any diver's reach, geometric forms surfaced on their screens. Smooth stone blocks as large as 10 feet. Sharp angles. Apparent plazas are divided by linear corridors. Even shapes that rose and dipped like eroded pyramids. Zalitsky spoke of it as if it were once a vast settlement. The images hinted at order, scale, and deliberate construction. And then came the silence. No excavations followed as Cuba authorized no new dives. The initial remotely operated vehicle that captured blurred footage was never replaced with one capable of higher resolution. The project stalled under the combined weight of crushing depth, extraordinary cost, and geopolitical restrictions. For more than 20 years, the discovery sat untouched, like a sealed vault on the seafloor. As researchers attempted to interpret those few images, one obstacle towered above all others: the depth. Supporters of the man-made city theory argued that natural geology rarely organizes itself into such precise lines and repeating forms. Weinsweig maintained that the structures could not be explained geologically. That claim alone pulled the conversation toward older and more unsettling questions about lost civilizations, forgotten coastlines, or an epoch when human history may not yet have been written down. But the numbers pushed back. If the site had once stood on land, sea levels would need to have been 700 meters lower than today. Yet at the coldest point of the last ice age, oceans dropped only about 120 meters. And when Cuban geologist Manuel Iturralde Vinent estimated that this section of seabed may have required as much as 50,000 years to sink to its current depth, the theory of a prehistoric city collapsed under its own impossible timeline. No known culture existed that far back in the region, let alone one capable of construction at scale. This is why the natural formation theory took precedence. Submarine volcanic activity, tectonic fracturing, and the breaking of granite can, under rare conditions, imitate architecture. Michael Faught, a specialist in underwater archaeology, emphasized that even though the shapes appeared out of place, they were still more consistent with geological processes than human design. Yet the mystery only deepened, because acknowledging nature's role did not dismiss the strangeness, it simply shifted it. The Cuban structures sat in a peculiar space between the credible and the impossible. And scientists had seen this kind of ambiguity before. Off the coast of Japan, The Yonaguni Monument had once sparked a similar debate. Its terraces dropped sharply, with right-angled steps that seemed drafted rather than eroded. For years, that formation forced geologists to reconsider how stone behaves underwater. But what made Yonaguni relevant to Cuba was not its shape. It was the lesson it taught. The ocean can create illusions so architectural that even experts hesitate. Still, Yonaguni had one advantage the Cuban site did not. It was accessible. While Cuba's anomaly, on the other hand, remained locked at a depth where even remotely operated vehicles struggled. While scientists wrestled with interpretations, a very different underwater discovery emerged and disrupted assumptions about what lies hidden beneath the waves. In the early 2000s, Frank Godillo uncovered Thonis Heraclean, a city long dismissed as legend. Unlike Cuba's deepwater mystery, Thonis Heraclean sat much closer to shore, only 6.5 kilometers out. But it demonstrated something critical. Entire urban centers can vanish beneath the sea and leave behind structures that appear impossibly intact. Except that Thonis Heraclean did not sink in a single dramatic event. Geological cores revealed a slow betrayal. Unstable clay, rising seas, and occasional earthquakes gradually loosened the earth beneath the city until it succumbed in the 8th century after Christ. It showed that a city can slip away, grain by grain, quietly, invisibly, until the ocean becomes its archive. Even more complications emerged from Pavlopetri in Greece, a Bronze Age settlement submerged gradually by tectonic shifts and rising waters. It was first mapped in the year 1968 by oceanographer Nicholas Fleming, and excavations began in 2009 under a joint British-Greek project. The layout of the ancient city, including streets, buildings, courtyards, and tombs, is still clearly visible on the seabed. Unlike those cities devastated by sudden catastrophe, Pavlopetri appears to have been abandoned slowly as encroaching waters made habitation impossible, offering a contrasting insight into how early communities adapted to environmental change. Its streets remain clearly visible today, revealing how natural sinking can retain human patterns with remarkable clarity. But in China, Shicheng demonstrated the opposite extreme. And unlike the others, this city did not sink through natural disaster or gradual erosion. Founded over 1,300 years ago during the Eastern Han Dynasty, it was intentionally submerged in the year 1959 to create the Qiandao Lake Reservoir for the Shinan River Dam. Protected by the cold, deep fresh water, the city preserved its elaborate Ming and Qing architecture with remarkable clarity. Interest in the site revived in the year 2001, and since then it has attracted advanced archaeological divers who explore intact walls, arches, temples, and intricately carved stonework. Together, these cases acted as a growing pressure on one question: what exactly lies off the coast of Cuba? A natural formation that only mimics intelligence, a geological oddity shaped by forces we still misunderstand, or evidence of a chapter of human history so distant and so deeply submerged that it resists every current timeline. But the ocean does not only swallow ancient worlds, it swallows modern ones too. And unlike forgotten cities or collapsed coastlines, these ones are slow intruders forcing the seafloor to change in ways that defy science. The sunken machines. When the container ship MSC Elsa III went down off the coast of Kerala in early 2025, it was not merely a maritime accident, but the beginning of a long disturbance that rippled outward from the depths. The ship carried calcium carbide, oil, and an assortment of hazardous materials sealed inside its steel containers. Once the hull settled on the sea floor, the pressure and temperature changes began to stress those containers, and the chemicals inside pushed through seams, valves, and fractured edges. For months afterwards, plastic pellets streamed into the ocean like a slow-motion leak from a ruptured artery. They floated ashore across more than 300 kilometers of coastline, embedding themselves into beaches, mangroves, and fishing grounds. Communities were forced to halt their livelihoods as the pellets infiltrated nets, boats, and market supply chains. But under the waves, the effects were even worse. The slow leakage from the containers continued, altering water chemistry, poisoning bottom dwellers, and creating microzones of toxicity around the wreck site. This is one out of many global situations where the sea has been poisoned by a shipwreck. In fact, the sea floor itself has been reshaped by collisions between human machines and underwater terrain. When the nuclear submarine USS San Francisco slammed into an uncharted seamount in 2005, the impact was violent enough to crumple thick metal plating. This demonstrates the unimaginable force with which a high-speed submarine meets the unyielding stone of the abyss. The collision instantly crushed marine organisms that lived on that seamount. Sessile corals hundreds of years old were obliterated in seconds. Sediment clouds erupted and drifted through the surrounding water for weeks, disrupting filter feeders and burying fragile microhabitats. Some wrecks, however, appear calmer and almost pristine when discovered. In 2025, when the French Navy located a perfectly preserved 16th-century Italian merchant ship at a depth of 2,500 meters in the Gulf of Saint-Tropez, the vessel looked as though time had slowed around it. Ceramic plates lay stacked inside the hull. Iron bars were arranged just as the crew had left them, and the ship rested so gently on the seabed that centuries of currents had barely shifted its structure. For a moment, the images taken by the remotely operated vehicle gave the illusion of a peaceful coexistence between human history and the deep sea, as if the ocean had quietly protected the vessel and allowed it to become part of the natural landscape. But that moment of calm collapses immediately when the wider camera angle shifts. Mixed among the 16th century relics are modern beer cans, plastic bottles, yogurt containers, and tangled synthetic fishing nets. With every tide or current, new debris settles on its timbers and fills the cavities between ceramic bowls. Microplastics drift down and lodge between objects untouched for hundreds of years. With time, the ship becomes a gathering point for everything humans discard, absorbing a second unintended cargo of synthetic waste that will remain long after the wood decays. Another thing is that wrecks inevitably attract marine life. They provide structure in places that are otherwise flat or barren, and deep-sea creatures evolve to exploit any available shelter. Corals attach to iron beams, and crabs slip into corroded openings to escape predators. Over years, sometimes decades, a wreck becomes an artificial reef, creating height, texture, and hiding spaces where none existed before. But this benefit is always laced with danger. The very surfaces that provide shelter also concentrate toxins. Paint flakes fall away in clouds, releasing heavy metals into the sediment. Fuel residues and hydraulic fluids leak from trapped compartments. Plastic insulation and rubber linings break into smaller particles that saturate the surrounding habitat. At the end, the same juvenile fish that find refuge under a tilted hull also absorb microplastics through their gills. Even the immobile organisms would accumulate toxins inside their tissues, which then pass up the food chain into larger predators. As decades pass, the wreck's structure weakens and collapses into itself, sending sharp fragments outward like shrapnel. This process destroys the very habitats the wreck once created. Crabs are crushed inside closing cavities. Corals are sheared off their anchor points. Fish lose the three-dimensional refuge that once sustained them. The ecosystem surrounding the wreck shifts abruptly, and deep-sea predators move in to feed on the disoriented remnants of the community that formed there. Deep wrecks, in particular, rewrite ecological boundaries. At depths where life moves slowly and resources are scarce, a wreck introduces a sudden pulse of metals, plastics, chemicals, organic cargo, and biological remains like a feast. As microbial blooms digest new compounds released from the structure, they erupt. This burst of microbial activity consumes oxygen, changes acidity, and creates chemical gradients that spread into the broader water column. Larger creatures move in to feed on the microbial mats or on the animals drawn to the wreck, transforming the area into an unnatural feeding ground. Over time, this alters predator-prey relationships and can shift entire deep-sea communities away from their original balance. Check out the videos on screen for more unbelievable stories.